Let's begin Chapter 3, The Chemistry of Climate Change. Part 1. We'll be talking about the greenhouse effect, and we'll look at evidence for global warming. We want to answer such questions as, what is global warming? Can anything be done about it? Is there really cause for alarm? And how can we assess the information we obtain from the popular press? How can we look at that information and draw our own conclusions and see if they agree with the conclusions from either the media source or the author? Here, this picture on the right is an artist's rendition of what is called geoengineering. It is some kind of craft that has these spiral-looking smokestacks coming out of it while sitting on the surface of the ocean. The idea is to mitigate the effects of global warming. They can use water vapor from the ocean to create essentially clouds which would deflect some of the light from the sun. Hopefully we won't have to do extreme measures such as this one, but it may come down to it. Hopefully you've realized by now that it's better to get the Earth on a sustainable path than to have to try and dig ourselves out of a hole. What's the worst that could happen? I like this cartoon because even if you don't agree with global warming, almost everything we're going to try and do to mitigate global warming seems like a positive change. Energy independence, protecting our rainforests, sustainability, green jobs, and so on and so forth. I mean, say we're wrong. Say all the data that's out there was misinterpreted, and we don't warm that significantly. It would certainly be a shame if we actually improved our cities, made them less polluted, and switched to renewable, sustainable resources. That would be a bummer, wouldn't it? I mean, I don't understand why people can't just see the value in fossil fuels. So first we're going to watch a little video that's an introduction to global warming. Now let's focus in on the greenhouse effect and actually look a little bit at the difference between the greenhouse effect and global warming. The greenhouse effect is when gases in our atmosphere reduce the amount of heat that escapes into space. This trapping of heat by our atmosphere is the greenhouse effect. Without our atmosphere and the gases in the atmosphere to trap some of that heat, our average global temperature would be closer to -18 degrees Celsius than the 15 degrees Celsius average it is now. So the greenhouse effect is necessary. A certain portion of the sun's energy, if we start with 100%, is absorbed by the Earth and the atmosphere. Some of it is reflected by the atmosphere, some is reflected from the surface. Once that energy is absorbed, some is emitted from the surface, some is reabsorbed into the atmosphere, and then some is emitted from the atmosphere. So it's this process which consistently has a certain amount of heat trapped to maintain a constant temperature. So let's take another look, more in-depth look at the greenhouse effect. Another analogy for the greenhouse effect is sun hitting a car whose windows are up. The sun passes through the windshield, and not all the heat can escape. Maybe if the windows are cracked, some of the heat can escape. And eventually, assuming the position of the sun didn't change and the temperature outside didn't change, we would reach a constant temperature within the car, with the sun maintaining the heat level, some of the heat leaking out of the windows. And that's essentially what's happening on Earth. Thinker Buddy question. How does the term greenhouse effect differ from the term global warming? The terms A, do not differ at all but refer to the same thing. B, greenhouse effect refers only to processes in a limited region of the Earth's surface. Global warming refers to processes that are global in nature. C, global warming refers to the return of heat energy to the Earth. Greenhouse effect refers to an increase in that effect caused by increasing concentrations of greenhouse gases. Or D, greenhouse effect refers to the return of heat energy to Earth. Global warming refers to the increase in that effect caused by increasing concentration of greenhouse gases. The correct answer is D. The greenhouse effect happens naturally. We need a certain amount of the greenhouse effect in order to have a comfortable planet to live on. Global warming refers to amplification, essentially, of the greenhouse effect, an unnatural increase in the greenhouse effect, increasing our average temperature, and mainly due to increasing concentrations of greenhouse gases. There are a few other optional videos posted on D2L if you'd like to explore them. They may help give you a rounded picture of the phenomenon, but we are going to talk about some of the information in this lecture and in later lectures. Now, what we want to do is look at the evidence. What is the evidence telling us? Is there significant global warming? Do we really have to worry about it? One argument that people like to give is, throughout history, we've had variations in our climate. There have been 30 glacial interglacial cycles over the last 2.5 million years on Earth. Ice age, we warm up, we cool down, we warm up, we cool down. The sea level has risen since the last ice age because we're in a warming cycle. And there are even short-term cycles. You might have heard of El Nino and La Nina. These are due to solar energy cycles, and they influence our weather patterns in about 10 years, every 10 years or so. We need to determine if we're actually having an impact, improve it. One of the things we want to look at or question, what would be the difference in a gradual change in CO2 concentration versus a rapid change? Would that have an effect on how quickly we might need to move out of low-lying areas closer to the oceans, or perhaps how animals migrate and adapt to temperature change? Are anthropogenic or people-made sources of greenhouse gases significant? There are other things on the globe that release greenhouse gases, such as volcanoes. If what we produce in terms of CO2 is significant, how do we prove that? And how do we assess the impact? Here's our first piece of evidence that there has been significant changes in CO2 concentration. At the Mauna Loa Observatory in Hawaii, there have been a significant increase in measured CO2 concentration. Now, there are seasonal fluctuations in CO2 concentration, but again, this black line here is taking an average, even including those fluctuations. And you can see since 1960, the concentration of CO2 has increased 60 parts per million. Recently, I saw an article that announced measurements as high as 400 parts per million. Additional evidence is found in ice cores. What they can do is drill deep, deep, deep into glaciers, into ice that has been untouched for hundreds of thousands of years. And very tiny, tiny bubbles in the ice cores can be carefully extracted and the CO2 concentrations measured. So at a particular observatory in Vostok, they were able to take ice cores in different depths of the glacier and record the variations in CO2 concentrations. And yes, they vary. We have these cycles of varying CO2 concentrations that are somewhat natural. But wait a minute. In the past 400 years, we had this nice little cycle, but all of a sudden, uh-oh, it seems like the CO2 concentration is skyrocketing. This is not natural. It seems like we are making an impact. The current concentration of carbon dioxide has been measured 100 parts per million higher than any time in the last million years. This is science. We measured the concentration. There's no question of belief here. Where there may be uncertainty is what impact that increase of carbon dioxide has. Now, if you want to compare the ice core data to the concentrations measured in Hawaii, we see this nice correlation. It's starting to increase, 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 and it continues on. That data agreeing very well with what we see in the ice cores. There's other data as well, in addition to carbon dioxide measurements, evidence that, yes, in fact, it is having an impact. And it is most likely due to anthropogenic sources of carbon dioxide. If we take all the temperatures on the Earth and average them, we can come up to some kind of value. And this graph here sets the temperature relative to an average, and it just shows the change relative to that average. The red bars indicate the average temperatures for each year, and the black bars here with the little lines on the top and bottom show the error range. So there is a significant degree of potential uncertainty here. But even taking that into account, it does appear as if we are getting warmer. Now, when we're thinking about uncertainty in data, what causes that uncertainty? Do all measurements have uncertainty? If you see a graph in a newspaper or a magazine or online that made a measurement of some type, if it doesn't show uncertainty, does that mean there is no uncertainty? All measurements have uncertainty. Now, the uncertainty might be very small, say for the atomic clock in Colorado, or it might be very large if you're trying to approximate the width of a room by putting one foot in front of the other. But no matter what the measurement is, there is some uncertainty. Very frequently, uncertainty isn't shown visually in the media. It may have in small print somewhere plus or minus 5%. Data you might commonly see is during elections. They might have It's very close race. Somebody has 45% of the vote based on our polls, and somebody else will get 43% based on our polls. And then you look at the print below, and it may say plus or minus 5%. If the difference between the poll values is less than the potential uncertainty in error in the measurement, can you really make a conclusion or draw a conclusion about the polling results? So this is just a visual display of the changes in specific regions in terms of average temperatures, and the most dramatic are shown in red. So we've seen some cooling in some regions and a significant amount of warming in others. Thinker buddy question. Given that direct measurements of the Earth's atmospheric composition over the last several thousand years are not available, how can scientists know the fluctuations in concentrations of carbon dioxide in the past? A. Ice cores drilled at the Vostok Station in Antarctica have been analyzed. B. Computer modeling of the composition of primitive atmospheres has produced the evidence. C. Current CO2 measurements are combined with information on the alignment of magnetic fields in dinosaur bones. D. There are not significant fluctuations in CO2 concentration. It is clearly steadily increasing. The correct answer is A. These ice cores have been invaluable. In a way, they're snapshots into the past. We have seen fluctuations in CO2 concentrations. But remember, none of the recorded CO2 concentrations in the ice cores have shown the level of carbon dioxide that we have today. We're 100 parts per million higher than any previous measurement in the last 400,000 years. This ends the first part of Chapter 3, covering sections 3.1 and 3.2 in your text.